Hi friends, in the automatic transmissions, so far we have covered about the planetary gears, clutches and pistons and hydraulic system. Now in this video, we will talk about the electronics involved in the automatic transmissions. Now all the present generation automobiles are fitted the latest model automatic transmissions which run through the electro-hydraulics. So what is mean by the electro-hydraulics and which are all the electronic components and what is their job in smooth functioning of the automatic transmissions we will discuss in this video. The technology advancement in the transmission design paved a way to introduce the automatic transmissions, what we discussed in the previous video. Okay. The shifting of the gears manually is completely eliminated and also pressing of the clutch pedal is eliminated. Two operations are eliminated from the driver, making the driving is very easy and smooth to the driver with less possible efforts and stress. Okay. So engineers haven't stopped there. The further advancement have paved a way to the modern transmissions which are called as electronically and hydraulically actuated automatic transmissions. I repeat, electronically and hydraulically actuated automatic transmissions. Why electronically and hydraulically means in the earlier version of automatic transmissions, hydraulic oil used to flow these various valves. Okay, different valves were there in the control valve. Okay, depending upon various factors, the control valve used to modularize or synchronize the oil flow based on so many inputs taken from the driving vehicle and supplies the oil through various components like clutches and some other valves for the smooth shifting of the gears. Now the movement of these spools is taken care by electronic components called the solenoids, electric components, which are also called as the transmission solenoids. In the earlier transmission control valve, you might have seen only one or two solenoids are there for some specific purpose, whereas you can see here almost every spool is controlled by the electric solenoid. You can see the same thing here. The inside one, this which are inside this is the valves, okay, and which are controlled by these solenoids. You can see this control valve fitted to this transmission. See all these which are in line, the cylindrical ones are the solenoids. Okay. But how these solenoids will work? Okay, and why the solenoids are required? Why not direct fluid actuation here? Because the main purpose of this solenoid implementation, solenoid addition for the movement of the spools is to have more precise shifting of these valves and more smooth shifting of the gears, because the actuation time from the solenoids will be in milliseconds, so which is more precise and more faster. So the smoothness in the shifting of the transmission gears is increased, so that the life of the components also increased. The solenoids will work based on the current received from a special unit which is called as the transmission control module, which I will be explaining in the coming slides. Okay, the transmission control module is again considered as the brain of the transmission. In the earlier case, we call the control valve is the brain of the transmission, conventional automatic transmission, whereas in case of this modern transmission control module or the transmission control unit is considered as the brain, because that takes the signals from various components of the vehicle, process those signals and give the signals out for the execution of engagement of the gears. The solenoid fitted in the transmissions normally looks like this. This body contains the electrical coil winding. Inside there will be a spool. This is the body having seal rings and also the passes, oil passes, and inside the spool is loaded by the spring. Okay, the solenoids can be two types. Normally closed solenoids means when there is no power, the solenoid passage is open, a normally open solenoid. This is kind of normally closed solenoid because when there is no power, the solenoid is closed the passage. When the power is applied here, the solenoid is opened and the oil passage is made through. How this works, any solenoid for that case, the current is supplied and this coil is energized and this plunger is pulled against the spring force. Okay, here, same way. The coil is energized, okay, the plunger is pulled up against the spring force, giving passage to the hydraulic fluid. Same thing happens inside this one, giving passage coming from one channel to the other channel. See, this is how this is a coil, this is a spring, okay. When it's magnetized, okay, it is pushed like this against the spring tension, okay. Oil supply is coming here. When it is pushed, this comes and matches here, allowing oil to go like this. When it is not energized, oil whatever is coming here will be going through this to the exhaust line. This is how solenoid functions. Every solenoid, you can see again once again the different parts of the solenoid. Okay, the cover, this is the winding, this is the plunger, and this is the spool, and this is the spring, this is the sleeve, this one sleeve which is housing the spool, and these are the oil passages. Okay. This is electronic part, this is electromagnetic part, and this is the electronic part. And whatever is coming, oil is coming from this. This oil will go and actuate the mechanical spools which are located in front of this solenoid. You can see this. This is the oil. This is the oil comes from this spool, and which actuates this valve again against the pressure, spring pressure. The movement of the spool, mechanical spool, depends on the amount of the oil supplied by this solenoid, and the amount of the oil supplied by this solenoid depends on the amount of the opening of the solenoid, and the amount of the opening of the solenoid again depends on the amount of current received by this solenoid coil, and amount of the current received by the solenoid is determined by the brain of the transmission, that is transmission control module. This is how the transmission control module looks like this. Okay, this is the complete body. Okay, when you open this cover, it looks like this. These two plastic housings, holes like this, terminals will be there, clippings will be there. One unit holds the input wiring from the input devices. The other unit holds the wiring to the output devices. The job of this transmission control module, somebody calls it the transmission control unit also, TCU, is to take the inputs from the various parts of the vehicle, process those inputs in this processor. This is a kind of computer. Process these inputs here and gives the signals through output wiring to the various solenoids to execute and engage the desired gear depending upon the dynamic road conditions. Okay. The purpose of this transmission control module is to take the inputs from various sources of the vehicle, process the inputs, and sends the signals to output devices, that is solenoids, to engage the appropriate gear depending upon the driving conditions. What are those input devices? Let us have a look. See this diagram. If this is considered as a transmission control unit, and this side are all completely the input devices, the blue one, and these are the output parameters or output devices. What happens? Let us have a look on one by one. The first one is the vehicle speed sensor attached to the output shaft of the transmission, where it senses the vehicle speed and sends signals to the transmission control unit to decide the changing of the next gear. Then the next one is the throttle pressure sensor. The throttle pressure sensor will come from the engine unit. because the throttle pressure sensor is connected to the engine ECM, that is engine electronic control module. So these two are the main input sensors for any transmission control unit, because this has to synchronize and balance between the transmission output shaft speed and the engine acceleration sensor, engine throttle position sensor. Okay, this has to synchronize and decide the gear shifting. In addition to these two sensors, the various other sensors are also important for the precise functioning of the gear shifting. Wheel speed sensor. Modern vehicles are fitted with a wheel speed sensor. The wheel speed sensors has been installed near the rear wheel to give more precise outputs, because sometimes there will be drive slippage in the vehicles on account of various road conditions. Tire slippage will be there, road slippage will be there. To take care of all such abnormalities and to increase the precision levels, the inputs will be taken from the wheel speed sensor. Then this is the turbine position sensor. This is actually called as turbine speed sensor. This determines the input shaft speed of the transmission. Okay. Here the throttle position sensor, here the output speed of the transmission, here the input speed of the transmission. See this one. This sensor gives the signal to the TCU about the input shaft speed, whereas this sensor will give the signal about the output shaft speed. So it listens to this also. Then the transmission fluid temperature sensor. This is also important. Because why it is important? Normally when the transmission fluid exceeds the desired level of temperature, its viscosity drops down. When the viscosity drops down, it affects the clutch engagement. Sometimes clutch slippage takes place. Further overheating will lead to the wearing of the clutches and wearing of the mechanical components in the transmission. The other main important use of having the input from the transmission fluid sensor is that one, when the temperature increases, the viscosity oil is dropped, so that there is a very possibility the main pressure also drops as the viscosity drops. So in that condition, the TCU can send the signal to the main pressure regulator valve to adjust the main pressure accordingly, in spite of there is increase in the temperature or drop in the viscosity. That's why it takes the input from the fluid temperature sensor. Then traction control system, okay, maybe cruise control system, which is installed in the latest type of vehicles, brake light, all these things and all. There will be some more sensors, input sensors based on the various models of the transmission. So this process all these signals and gives the signals to the following units. Shift lock. In the conventional system, we have seen that we can mechanically lock that shift lever, allowing the oil to the desired ports. That may be drive to all the forward clutches one by one. In the neutral, it will be neutral. No oil will go to the clutches. Then reverse goes the oil only to the reverse. Okay. In case of this, the actuation of the shift lock occurs based on the signal given by the transmission control unit. Simultaneously, the signal goes to the shift solenoids. Earlier case, the shift signal valves used to operate based on the oil pressure received from the main pressure regulator valve in combination with the other valves. In this case, the signal goes to the shift solenoids to operate the shift spools connected to the various clutch discs in the transmission. Then another signal goes to the engine control module also. Normally this signal goes when the vehicle speed is increases and the vehicle is traveling down the hill, there is a possibility of overrunning, the increasing in the speed of the engine. In such case, it send the signals to cut off the fuel supply to the injectors for a momentary cutoff of the fuel to the some of the injectors, so that the engine speed is kept under control. Sometimes the signal also will be sent when the engine speed is beyond the required limit. This is mainly to save the fuel and also to minimize the wear and tear of the engine moving components. Then the another signal will go to the torque converter clutch solenoid to supply the oil to actuate the lockup clutch in the torque converter. Turbine and pump of the torque converter runs at same speed, the lockup clutch is engaged. Okay, this is how. Here you already have the turbine speed sensor. The turbine is connected to the input shaft of the transmission, and from here it takes the signal and passing on to the lockup clutch. Both turbine and pump are rotating the same speed. Now you give and engage, so that the complete torque converter will be rotated as a single unit by becoming the torque multiplication 0. Then the pressure control solenoid, but main pressure regulator valve, what we discussed in the earlier version. The main pressure is controlled through this solenoid, again taking various parameters. Okay, this is how the inputs to the TCU processing through the processor and sending the outputs, and finally going the desired quantity of the fluid at desired rate to the respective clutches. I told respective clutches, and also disconnecting the running clutch and engaging the next clutch, like that for smooth engagement. Okay, this you can see here: clutch back, planetary gears, that is sun gear, ring, and planetary gears. Okay, this is how electronics will function in the automatic transmission. In case you have any queries, you can always contact me through email. 3 pages notes which will be useful to you.